This is the 5th Mesh 2 online class, and in today's class we will solve some textual question from exercise 11.1. But before we go to the question, let's revise the formula that you learned in the last class, which is section formula. According to the section formula, if this is a line, let's say this is the first point, we can call this one point P. This is the second point Q, and now 2 points P and Q are joined. Then we get a line segment PQ, and the coordinate of point P are x1, y1, like that coordinate of point Q x2, y2. Then now line segment PQ is divided by another point, let's say this is point R, such that the ratio of PR to PQ is m:n. Then the coordinate of point of division, which is R, is given by xy, and here it is mx2 plus nx1 divided by m plus n, and my2 plus ny1 divided by m plus n. Here x stands for abscissa, and the value of x is this first expression, and y, which is ordinate, this value is the second expression, which is my2 plus ny1 divided by m plus n. So this is called section formula, and this is the formula you learned in the last class. We even derived this formula. So using this formula, we're going to solve some question today. And one of the deduction of this formula is, now let's say we have the same line segment PQ, and here point R is now midpoint. Here midpoint means from P to R length is equal to R to Q. That means ratio m:n is equal to 1:1. So coordinate of midpoint, which is given by xy, this line PQ is joining x1, y1 and x2, y2. Then the coordinate of this midpoint R is given by x2 plus x1 by 2 and y2 plus y1 by 2. You already learned in the last class how we get this from the main section formula. Then we will straight away to go to the textual question. That is the question number 1 of exercise 11.1. Question is, find the coordinates of the point which divides the line segment joining the points 3, 6, 3 and -4, 5 in the ratio 3:2 internally. Now in the question we don't see m, n, x1, y1, x2, y2. But now I'm telling you, here we have 2 points. Now line segment is joining these 2 points. So you take the first point to be x1, y1, and the second point to be x2, y2. Then now we know which one is x1, which one is x2, y1, y2. First point take x1, y1, second point take x2, y2. And you can see here ratio is 3:2. So there is the value of m:n. That means m value is 3 and n value is 2. Then now we are going to use section formula to find coordinate of the point of division. Then we start, let xy be the required point. Let xy be the coordinates of the point which divide this line segment in the ratio 3:2. Then by section formula, see, we will not use write again the exact section formula here. According to section formula, x value is mx2 plus nx1 divided by m plus n, and this is y value. So now to find x value, let's see, using section formula. Now, how do you find x? There is expression for x. X is equal to 3. What is 3? 3 is m value. So here in the formula m, so we write in place of m value is 3 into m x2 means m into x2. X2 value is into x2. I said the second point, x2, y2 value. So x2 value is -4. So we put 3 into -4. Then in section formula, it is plus, we write here plus sign, then nx1, again n into x1. Here n value is 2, so we write 2 into x1. Again, the first point is 6, 3, in which x1 value is 6. So we multiply 2 and 6 divided by, in the formula, m plus n. So m value is 3, n value is 2. So we add 3 and 2. There is expression for x. Now let's see. We multiply this. 3 into minus 4 is minus 12. 2 into 6 is 12. 3 plus 2 is 5. Finally, minus 12 and plus 12 is 0. 0 divided by 5 is 0. Remember, 0 divided by any number is 0. Later now we'll find y value 2. To find y value according to section formula, my2 plus ny1 divided by m plus n. That means we have to multiply m and y2 value, then added by n into y1 value. So looking at these 2 points, we have m3 and 2. So y value m y2, here y2 value is 5, plus n y1, n is 2, y1 is 3. 2 into 3 divided by m plus n. 3 plus 2, again we get the same thing. Then 3 into 5 is 15. 2 into 6 is 12. 2 into 3 is 6. We add 15 and 6, we get 21 by 5. Now we cannot cancel this, so we write as it is. Then now we have x, which is abscissa. We have y, which is ordinate. Then we'll put them together to get coordinate. Therefore, the required point is, we have to write x value first. X value is 0. Y value is 21 by 5. So we write x value, comma, y value. This is coordinate. So this is the required point. So in this way, we will do another question. Here the question is, find the coordinate of the midpoint of the line joining the points 4, 7 and 6, 9. Here we are given 2 points. So the first one x1, y1, and the second point x2, y2. Now we may ask here, ratio is not given, because the question is to find coordinate of midpoint. To find coordinate of midpoint, we don't need ratio. The formula that we need is x2 plus x1 by 2 and y2 plus y1 by 2. We need x1, y1, x2, y2 value. So using this deduction of section formula, again we start, let x, y be the midpoint of the line joining the point 4, 7 and 6, 9. Then x value according to formula, y2 plus y1 by 2. y2 value is 9 and y1 value is 7. So x2 value is 6 and x1 value is 4. Section for midpoint formula, see, x2 plus x1 divided by 2. So here again I repeat, x2 value is 6 and x1 value is 4. 6 plus 4 divided by 2. 6 plus 4 is 10. 10 divided by 2 is 5. Later we find y value 2. Y value, to find y value, it is y2 minus y1 divided by 2. So here y2 value is 9 and y1 value is 7. 9 plus 7 divided by 2. 9 plus 7 is 16. 16 divided by 2 is 8. Then again we'll write this x and y value together, separated by comma. Therefore the required point is 5, 8. So these are the 2 textual questions of exercise 11.1. We will do one more question, but this question will be from example. There is example number 2. Yeah, chapter 11, example number 2. Here the question is, find the point of trisection of the line segment joining the points A, 3, minus 2 and B, minus 3, minus 4. Question is to find coordinate of, or the points of trisection, and the line segment is AV because the first point is A, the second point is B. So now let's try to understand this. Here is the line segment AV, A one point and B another point. So if we are to trisect this AV, then we have to divide into 3 equal parts. From A to P one part, B to Q another part, and Q to B another part. So here we divide AV into 3 equal parts. I repeat, 3 equal parts. AP is equal to PQ is equal to QB. Then we say that line segment AB is trisected at P and Q. So to divide a line segment into 3 parts, we need 2 points. So these 2 points P and Q are called point of trisection. So let P and Q be the points of trisection of AB. Then again, let's try to understand this. What will be the ratio? From A to P length is equal to P to Q length is equal to Q to B length. That means the ratio will be 1:1:1. Then now we are to find what is the coordinate of point P and what are the coordinates of point Q. So we have to find these 2 points. Then to find this, we have 2 points to be A and B. So x1, y1 value will be 3 minus 2 and x2, y2 value will be minus 3, minus 4. First point, second point. Then to find this P and Q coordinate, we need ratio. Now let's find the coordinate of point P. For this, AB is divided by P in the ratio from A to P is 1, from P to B, 1 plus 1, 2. So point P divides AB in the ratio 1:2. Then you can see here, then P divides AV in the ratio 1:2. Therefore, coordinates of P are, again we use the same section formula here, but I'm not going to show you again. You have to memorize the formula. Formula is mx2 plus nx1. Here you can see, for this P, m is 1 and n is from P to B, it is 2. 1:2. As you can see here, ratio is 1:2. Then x1, y1 value 3 minus 2 and x2, y2 minus 3 minus 4. Then according to this formula, we write m value is 1 here, and x2 value is, you can see here, minus 3, mx2 plus nx1. N value is from P to B, ratio is 2. Second part of the ratio 2 into x1 value, you can see the first point opposite side is 3, divided by m plus n, 1 plus 2. Then ordinate my2, m is 1 here, y2 is minus 4 plus ny1, n value is 2 and y1 value is, you can see here, minus 2, divided by m plus n. Then now we multiply 1 into minus 3 is minus 3, 2 into 3 is 6, 1 plus 2 is 3, 1 into minus 4 is minus 4, 2 into minus 2 is minus 4, and 1 plus 2 is again 3. Then you can see minus 3 plus 6. Minus 3 plus 6 value is 3, and you can see denominator also 3. Then minus 4 and minus 4 combined value is minus 8. Then 3 and 3 cancel, 1 is left, and ordinate minus 8 by 3. So we get 1 comma minus 8 by 3, which is the coordinate of point P, which is first point of trisection. And we have the second point of trisection, that is Q. Try to understand here again the ratio. Q divides AB in the ratio 2:1. Here Q, from A to Q ratio 2, and from Q to B it is 1. So ratio is 2:1. x1, y1, x2, y2 value the same, but only ratio is changed now. Ratio becomes now 2:1. Then you can see here again, Q divides AV in the ratio 2:1. Therefore, coordinates of Q are mx2, m value is now 2, n value is 1. x2 value is minus 3 plus n is now 1 and x1 is 3, divided by m plus n, 2 plus 1. Like that, my2, m value is 2, y2 value is minus 4 plus ny1, n value is 1 and y1 value is 2, divided by m plus n, that which is 2 plus 1. Then 2, 3 minus 6, this 3 is minus, plus 3 into 1 is plus 3, divided by 2 plus 1 is 3, 2 into minus 4 is minus 8, 1 into minus 2 is minus 2, 2 plus 1 is 3. Then minus 6 plus 3 value is minus 3, minus 8 and minus 2 combined value is minus 10, minus 3 by 3 cancel, we get minus 1, 10 cannot be divided by 3, so we get minus 10 by 3. So minus 1 comma minus 10 by 3 is the coordinates of point Q, which is the second point of trisection. Thus the points of tristation of AB are: the first point, that is coordinate of P, and second coordinate of Q are 1 comma minus 3 and -1 comma minus 10/3. So this is how we find the coordinates of point of tristation. This is the example question. So for today we are doing only these 3 questions. Then we will continue the same exercise either offline or online in the month of July.